All right, let's finish this one up. I think we just had the last two examples, right? All right, let's do it. So we're going to do this the same way that we did the last one. We're going to start with our parent function and track points as we go. So let's go ahead and get this started. What would our parent function be for this function? Again, square root y equals square root of x. And square root's kind of nice because we only have to track a couple points. I'm just going to remind myself what the square root function, parent function, looks like down here. It starts at the origin, it goes through 1, 1, and then it kind of curves like a sideways parabola, like half of a sideways parabola. So as long as we have those 2 points, then that should be enough to graph this thing accurately. So we'll start with 0, 0 and 1, 1, and then we'll start doing some transformations. When you're looking at that equation, how many transformations are you seeing there? You're seeing 3? Seeing a negative, I'm seeing something multiplying, something added. I'm counting 3 as well. How many of those transformations are on the outside? You seeing 2 on the outside, the negative and the 1/2? Okay, so those 2 are the only ones that we need to worry about doing in a particular order. The one that's on the if there's more than one in a particular location, then you got to worry about what order you do it in. Okay, so this 1/2 on the inside, we can deal with this at any point that we want to in the process, and it's not going to change the results at all. But I need to be strategic in thinking about how I want to deal with this +1 and this negative to make sure we end up with this thing. So would you guys like to deal with the vertical shift first or the reflection first? What do we think? There's no wrong answer here, but one of them is going to be a little bit more complicated. Let's say I deal with the reflection first. We would end up multiplying the entire function as it is right now by -1. It would become negative. And then if I did the shift later on, then I would still have that negative square root of x, and I would just take that entire function and add 1. Is that going to get me what I want? I'd say yes, absolutely. If we reverse the order, though, what if I did my +1 first? So now I've got square root of x plus 1, and then I did the reflection. When we do the reflection, we'd have to multiply the entire function by -1. Is that going to screw anything up? Because if we had a +1, then that, well, let me just write what it would look like. If I had done my +1 first, and then I wanted to come in and multiply by -1, I'd have to multiply the entire thing, which is actually going to result in us ending up with a -1, which is not what we want, okay? So now we could get clever about it, and what we could do is if you absolutely wanted to do that vertical shift first, we could shift it down instead of up. And then we could come back and multiply everything by -1, and that would get us where we're going. But do we want to get complicated like that, or do we want to take kind of the simple way? Okay, so, and this is that, I asked you guys to remind me about the cheat code. I remembered. We'll get back to that in a minute. Part of the cheat code is if you can get your function into a particular format, there's a really simple rule about doing the transformations, what order to do them in. And that rule is always shift last. If you can, try and shift last. So we're gonna do this shift last. Do you guys want to do the multiplication by -1 or the half next? We're gonna do the shift last. Someone pick. It doesn't matter. -1 or the half? Oh boy. Okay, the -1. All right, so we are going to multiply the entire function by a -1. We're multiplying on the outside. So what kind of transformation are we doing here? These guys said that it was going to be vertical. Multiplying by a negative is going to give us a reflection. And are we reflecting over the x-axis or the y-axis? We've got to be specific when we write this down. X or Y. We're moving vertically, right? Because it's on the outside. So if something's moving vertically, I think it's reflecting over the x-axis. We'll plot our points here, or tabulate our points rather. This is a vertical transformation. Is it going to be changing our x-coordinates or our y-coordinates? Vertical transformations always change the y-coordinates. So our x-coordinates are going to remain exactly as they were, 0 and 1. Y-coordinates are going to be different though. And we're reflecting, so we're just going to multiply each of our y-coordinates times -1. So 0 times -1 is still 0, 1 times -1 is -1. Morning. Acuplacer. Yes. All right. Thank you. Enjoy. Make us proud. All right. Let's deal with that half on the inside next. This is happening inside the function, so it's really important when I'm doing this that I think about, I'm not just multiplying the x times a half, I'm pulling the x out of the equation, multiplying it by half and putting it back in. It's on the inside, so it's horizontal. And we're multiplying by something less than 1. Is that going to be a stretch or a shrink? Multiplying by something by less than 1. Remember, it's inside, and inside is backwards from what you would expect, right? Normally, you think you multiply something by a number less than 1 and it would get smaller, but inside's backwards. So this is actually going to be a horizontal stretch by not a half, but the reciprocal of that. Horizontal stretch by 2. So multiplying on the inside is backwards from what you'd expect. Multiplying by something small actually stretches it out by whatever the reciprocal of that multiplier is. All right, let's track our points. Which coordinates are changing this time, x or y? This is horizontal. Horizontal things change the x coordinates. And we have to think about what's going to happen to a point if we're stretching horizontally by a factor of 2. So the x coordinate should be multiplying times 2. So y coordinates are going to stay the same as they were in the last step, 0, -1. The x coordinates are going to multiply times 2. 0 times 2 is still 0. 1 times 2 is 2. We're almost there. We just have that +1 to deal with at the end. And since we chose to put this at the end, we don't have to worry about parentheses or anything like that. We're going to be adding to the entire function, so just tack it on at the end there. I don't know why I moved my table. Adding on the outside is going to be a shift. Which direction, though? Up, down, left, right. +1, up by 1. You could draw an arrow. And which coordinates change when we're shifting up and down? X or y coordinates? Y coordinates would change. We're just going to add 1 to each of our y coordinates. The x coordinates will stay the same, 0, 2. Y coordinates are going to change. So we're adding 1 to 0 gets us 1. Adding 1 to -1 gets us 0. Now we should have enough to sketch this thing. All right, so our first point is at 0, 1. That's here. So that's where it's going to start. And then it needs to go through 2, 0, just here. All right, remember, these square root graphs are going to start at the first point, and it's going to go through the second point, and then it's going to sort of flatten out after that. So when I draw my curve, I'm going to have it go through here and then sort of flatten out. It never truly flattens out, but it curves more towards the horizontal. Any questions? Are you guys all exhausted today or what? It's because it's Friday, it's first thing in the morning? Okay. All right. Okay. Last one. A graph G is obtained from the graph by the sequence of transformations indicated. So this time around, sequence, the order does matter, so we'll have to be careful about that. We'll go ahead and write our equation, and then I'll come back and show you the cheat code. I keep trying to repeat it so I don't forget. All right, so here we go. Let's do this. We're going to start with y equals x to the third, which is our parent. And then we'll go through the steps. So first step is to reflect over the x-axis. We need to think when we reflect a point over the x-axis, is that point going to be moving up and down, or is it going to be moving left and right? If I've got my x-axis here and I'm reflecting over that, it seems like that point's going to be moving up and down. Do you guys agree? It's moving up and down. Okay, so that's going to be happening on the inside or outside of our function. Up and down stuff happens on the outside. So we just need to take our entire function, x to the third, and multiply it by -1. So we'd end up with a negative out there. All right, what do they want us to do next? Horizontal, shrink by a third. All right, shrinks and stretch mean we're going to be multiplying. The question is, are we multiplying the entire function, or are we pulling x out and multiplying it by something? And the key is horizontal or vertical. So horizontal stuff happens inside the function. We accomplish it by pulling x out of the function and then replacing it with something else. So let's go ahead and yank that x out. And what do I do to an x in order to get it to shrink? Now keep in mind it's on the inside, so it's backwards, upside down from what you'd expect. Normally we'd think if we wanted to shrink by a third, we multiply it by a really small number. But we're actually going to multiply it by a bigger number. We're going to multiply it by the reciprocal of this. So we pull that x out, we replace it with a 3x. All right, next, shift up 5 units. All right, that's vertical, so that's going to be happening on the outside. So let me copy my function down, and then we'll do something to the entire function. So if I'm shifting up, that would be addition to the entire function, so plus 5. And finally, left 6. All right, left is horizontal, so we need to take the x out, do something to it, and replace it. So let me get this set up here. I'm going to change these into brackets. I'm pulling my x out. So that's the same equation we were just dealing with. We've just got parentheses inside of parentheses. These could be parentheses too. Inside an equation, parentheses and brackets mean exactly the same thing. So we pulled the x out, and we need to replace the x with x minus 6, x plus 6. X plus. It's backwards, right? You'd think it would be minus, but it's actually plus. And there we go. That would be our final equation. We could distribute this 3 if we want to, but I would say I would just leave it like this. Okay. Any questions on that before I tell you about the cheat code? Okay, so here's the deal. If you can get a function into a format that looks like this, where, and really it's kind of the inside that makes a difference. On the inside, if anything's multiplying by the x, you want it to be multiplying kind of outside of this set of parentheses. I'll give you some more examples, but here's the cheat code. If you can get it into this format, then the simple rule about what order to do things in is just do your shifts last. Doesn't matter what order you do your shifts in. It doesn't matter what order you do any of the stretches or reflections that happen. As long as all the stretches and reflections happen first and the shifts happen at the end, then the order will not be affected if it's in this format. So I want to go back to the front side here and look at this problem that we did at the beginning. If I had taken this function, I'd say that function is not in the format that I was looking at on the back side. It's not in the format because something's being multiplied by the x. We want that x kind of in its own parentheses. We want to factor that thing out that's multiplying in front of it. So I want my x to be by itself inside some parentheses. Anything adding or subtracting needs to be separate in the parentheses, and then anything multiplying is on the outside. So I want to pull that -2 out, which is going to change. It's not longer going to be a +6 in here. You guys know how to factor stuff out, though. What's this going to change into? -3. So if I wrote it, if I took this problem, I wrote it in this format right away, then when it comes to figuring out how to do my shifts and my reflections and my shrinks and all that stuff, the rule would have been really simple. I would have done my shifts last, and when I would have done my reflection and my shrink beforehand. Now we were able to pull it off doing it in a different format, but this just kind of makes everything pretty simple. When we get into second semester, we're going to be graphing equations of sine and cosine, and you guys are going to be able to look at something like this. And graph it by hand without a calculator. And we'll be looking at it in this format. Can you kind of see how that's similar to how we did this here? We're factoring something out here. So what is this? This is just your sine parent function. It's been stretched vertically by a factor of 4. There's a shrink or a stretch horizontally. I'm not too sure. I'll show you how to figure that out later. And then at the end, I would do the shifting to the right by 2 and up by 1. So you can you can always fall back on this. But if you ever run into a problem and it's not in this format, if you force it into this format, then the simple rule is do your shifts last and you'll be fine. All right, any questions? I want to go over questions from the assignments, so if you guys could get your assignments out. Grab my book here. We'll start with 1.5. I'm hopeful that folks got a healthy start on